All right, so the first announcement is that we won't have class on Thursday. If you look at the course schedule, you'll notice that there's a makeup day scheduled for later in the semester in a couple of weeks. So what we're going to do is we're going to move that makeup day to this Thursday, which is when I'm going to be out of town working on the Fundamentals of Engineering exam down in Clemson. And so we will have class on what was originally going to be called a makeup day later in the semester. So don't come to this room on Thursday unless you want a nice quiet place to study. Then that's fine. Today we're going to continue talking about Matlab. You don't have an assignment on the books right now. You will get one a week from today. When we get back to class on Tuesday, I'll give you the next assignment. But we're going to continue talking about Matlab, and specifically we're going to begin discussing arrays, which is just another word for a matrix. We're going to get into polynomials and basic plotting. So if you haven't already, go ahead and start up Matlab. Today's class is going to be interactive. I'm going to show some commands on the screen that I'd like you to get experience with. I'll make a suggestion that you take notes today. As you were working on the assignment that you submitted, probably you had to go back through the videos to remind yourself how certain commands worked, right? Just for maybe the syntax of the commands. Maybe you knew exactly what the command was supposed to do, but you didn't know the order that different inputs went into the fields. And so it's fine. Those videos are there. You can go back to them and you can review the lectures. And as I showed you before, there's lots of ways to get help on Matlab. You can go into the help files. You can do a search online. But then another way for you to be prepared for the assignments as they come up is to take your own notes on the formatting and syntax of different commands. All right, so what we're going to be talking about today is one-dimensional arrays. And an array or a matrix is a series of variables. Well, it's a series of numbers that we can assign to a variable. And so it's a group of numbers. It may be polynomials or representations of equations. And having a group of numbers assigned to a single variable is a very powerful thing because it allows us to do calculations calling on one variable and it representing a whole group of numbers. And so it's really going to take the capabilities up to the next level for us. So we're going to be working exclusively in the command window today. And if you have Matlab open, remember there's lots of different windows and one of them is the editor. When you opened Matlab, it might have automatically loaded the last M file that you were working on. Remember this one that we did in class previously where it told us that if we didn't meet our goal, then we stink, our financial goals? So it was the computer insulting us. You can close that file just by clicking this, the X. That'll go away. And it will maximize the command window, which is where we're going to be working. And in fact, you don't have to do this, but what I'm going to do is I'm going to drag these other windows to the side because I want to capture both PowerPoint and Matlab today, and so I'm trying to kind of conserve my space a little bit. So it gives you the ability to adjust the widths of windows to whatever suits you. All right, so what I'd like you to begin with is by defining, remember how things work when you define a variable x equals 5, and then having the semicolon there suppresses the echo. So if we do that, if we do x equals 5 and suppress the echo, we get no return. But then over here we can see that the variable x is a 1 by 1, which means one row, one column. It's just a single value. And here is the value itself, 5. And if we wanted to call on that, just to make sure here in the command window what's assigned to x, we can type it in and it will call on that variable and repeat it to us. Now, we can make a one-dimensional array in the same manner. Let's just type in x equals and then put in the brackets here. Now, these brackets help to indicate to Matlab or Octave, whichever you end up using at home, ends up telling it that we are creating an array, which is a series of numbers rather than just a single one. So 5, 6, 8, 0, 4, 3.2. Now, a couple of differences you may notice. There are spaces after the comma between the next number. On the PowerPoint presentation, I didn't bother with those spaces. They're optional. You can put them in if it's your habit from typing, or if you want to save keystrokes, then you don't have to put them there. And additionally, the semicolon is also optional. If you don't mind it echoing once you type it in, you don't have to put it there. But if you don't want it to echo, then you put in the semicolon and it won't. So what we did was we just defined a new set of values for the variable x. And if you look here into the workspace, now what we had before for x, which was 5, has been overwritten with 5, 6, 8, and so on. And if I hover the cursor over the variable x, it now tells me it's a 1 by 6. And so a 1 by 6 means 1 row, 6 columns. So it can tell me how many variables are assigned into that value x. Now let me just make kind of a side comment today. We're going to be doing a lot of typing into Matlab, and maybe at some point what you do is different than what I've done on screen. I won't, unfortunately, because there's so many of us in the classroom, I won't be able to go to each one of you and troubleshoot what the issue is. In most cases, it's a typing error. And so you have to be really precise in the way that you type things in, and maybe I'll have a typing error today. That's just as likely as anything else. But in most cases, it's not that MATLAB has a bug or that your version of MATLAB is behaving completely differently than everyone else's version of MATLAB. It's usually just a keystroke error, that you've typed something in wrong, and that's why what you see on the screen is different from what we're expecting based on the activity. All right, so we've created our first 1D array. Now, even these commas aren't necessary. You can just put spaces if you like, but it's suggested in a lot of cases to use those commas just to help visually break up the numbers. And so we could redefine x again, just 5 space 6 space 7, oh wait, it was 5, 6, 8, 0, 4, 3.2, enter, suppress the echo, and it didn't change any numbers, but it's not like we're getting an error message or anything. We still have those same values stored into the workspace for the variable x, even without the commas. So a little bit about, in your notes that you're taking, the things that you should write is that arrays are defined with brackets. That's kind of the key differentiator between a single variable and a group of variables, is that the MATLAB is looking for that brackets, and then it will know that the series of numbers in between the brackets is what it should assign to the variable as an array. All right, so we've looked at the workspace, and if you double-click on x, it'll bring up a new window that we haven't seen before. So let's try that. Double-click on x, and it looks a little bit like Excel. You know, it's a series of rows and columns. And so this is a way that if we had a really extensive set of numbers assigned to a variable, this is a nice editor for going in and changing values. And so let's see if this actually does function as an editor. What if we wanted to change this value of 8 to 9? One way that we might be able to do it is you go in there, double-click, highlight, change it from 8 to 9, move to the next cell, and then you can see here in the workspace what used to be 8 is now 9. It automatically saves any changes that you're putting down in this variable editing area. So I'm going to change it back to 8. And here it's automatically updated in the workspace. Okay, now it doesn't just have to be numbers that we assign in the sense of an array. Try setting this variable y. It'll have 3 values. The first will be the log of 2.6, the square root of 3, and 5 to the 1.2 power. So we can put calculations into an array. But when you do those calculations, look at what it actually stores as the variable. Over here in the workspace, if we put that in, y equals log of 2.6 square root of 3 and the 5 to the power of 1.2. Okay? What did I do wrong here? Probably lacking. Oh yeah, it was here. I used a bracket rather than, so it's asking me, do you mean? It's correcting the mistake for me. Yes, that's what I mean. All right. Thank goodness for autocorrect, except when text messaging. Lots of misunderstandings over the years from that. All right, so it's storing the result of the calculations rather than the calculations as I typed them in. Okay? And by the way, if I want to get the full size of my command window back, I can close that variable editor, and then I get my command window back. I could bring that editor back at any time just by double-clicking on a variable in the workspace. Okay, so we can put calculations inside of the brackets, so it'll embed calculations within the array. And we can also put other variables into the array. So we've previously defined y in this line. So what you should do next is define x as the number 5. And then z you can define as pi, which it's going to understand as 3.14159 and so on. Y, which we've defined before, 9, and x. And so it will insert whatever numbers have been assigned to those variables inside of our new array, z. We'll have to be careful later on when we're doing 2D arrays, which would be more than just a single row, because we have to make sure that the right number of sizes exist so that there is, for each row, the same number of columns. But for here, we don't have to worry quite so much. So we've defined y already. Let me give x equals to 5, suppress the echo, and now z equals pi, y, 9, and x. Now, I haven't defined a z variable yet. Nothing's showing over there in the workspace. But once I do, I can open up the editor, or I can just I can ask for z to be reported here in the command window just by typing z. And then here it's going to tell me each of the column values. So here's the pi column. Here's 0.955, which was the value that we had gotten from log of 2.6. And so now you can see the result of its inserting y, which should have 3 values. So 1, 2, 3. These are the 3 values that came in from variable y. Here's the 9 that I manually defined within this array, and then it's calling on x to give it the last one. So what can we put in an array? We can put numbers, calculations, and other variables. And the array itself is created with the bracket sign. Those are some of the things that you should be putting into the notes. How to report an array is just type its variable and enter in the command window, or you can edit it by double-clicking on the variable in the workspace. We'll look at some other ways to edit arrays as well. Any questions so far? Okay. Typing this in would be tedious, right? I mean, it wouldn't be the end of the world. We have the time. We could type it in if we wanted. But what if you needed an array that was hundreds of numbers and it was evenly spaced? You wanted a pattern. Now this would be easy to do in Excel. Remember how we have the trick of you type in the first number or two, and then you can just drag the cells down and it'll automatically detect what the pattern is and fill that pattern. As long as you want to continue dragging, it'll do it. Well, there are similar time-saving tools available in Matlab. So one of them is, rather than just typing in a series of evenly spaced numbers, you can have this colon defines, it tells it essentially fill in everything in between in spaces of 1. Okay, so let's try that out. We already have a variable of 5 for x, but let's overwrite that with, instead of typing in 1, 2, 3, 4, and so on, let's just do x equals brackets 1 colon 10, end brackets, and let's not, although it says on screen to suppress the echo, let's not suppress the echo because I want it to report here in the command window the result of that operation. So I'm going to push enter, and sure enough, it tells me x is 1, 2, 3, 4, 5, 6, 7, and so on. Okay, so that's a really convenient way of defining variables. I mean, you can take it to extremes if you want. You could go to any number, and in fact, it doesn't have to be spacings of 1. You know, if it only had the option of spacings of 1, it'd still be useful, but there's even more application if we can do other spacings. So do this. Write down in the margins of whatever notes you're preparing, what would this mean? You know, if we typed in inside of the brackets 1 colon 7, what would that mean? Well, that is, if there's no central value, it's going to do groups of 1. So it would be 1, 2, 3, 4, 5, 6, 7. But now, this is a little bit different. We've got something in the middle, and that means the spacing between the beginning and the end of our pattern. So 1 is the beginning of the pattern, 7 is the end of the pattern, and we want Matlab to go in groups of 2, or skip. So from 1 to 3, 3 to 5, 5 to 7. So the result of that would be 1, 3, 5, 7. That is what it would assign. Those are the values that would be assigned to the whatever variable was on the other side of the equal sign when this is inside the brackets. So do you understand the methodology here? All right, so write this down. What would it be if it was 2 colon 2 colon 11? Write down what pattern would result from that. So what did you write? Anybody willing to take a crack at it? Go ahead. Good question. The answer is no. 11 is a hard limit. So knowing that 11 is a hard limit that can't be exceeded, then what's going to be in that array? Exactly. That's right. So it would terminate at 10. Matlab will go as far as it can, but it's not going to step over that bound. All right. So we can even do negatives, and we can go in reverse order for the assignments. So here it's saying 16 is our beginning, -4 is the stepping direction and distance, and then 0 is the end. So that means that the first component of our array will be 16, 12, 8, 4, 0. All right. So pattern detection is fun, right? All right. So that's how you define these lengthy arrays without keying them in manually, is you can use these colons, and the central value tells you the spacing, and then the beginning and the end tells you the bounds of the array. Now, when we're working with a 1D array, the brackets are optional, But it's a good habit to always be using the brackets because when you're working with 2D arrays, they're not optional. So it's better just to stay sharp and not get sloppy because you'll get error messages if you're working with 2D arrays and you don't use the brackets. So it's recommended that you do, just to help you distinguish between single variables and arrays. All right. Now, on the subject of helpful tools, ways that Matlab can make our lives easier, one of them is that it can do a linear interpolation, and it can space out the increments according to a certain number of variables you want rather than the spacing. So what I mean is, in this last activity, we knew how far apart it should be. So it was 2, 2, minus 4. Now what we didn't exactly know is how many values we were going to get. We knew the bounds and we knew the increment, but the difference between that and linspace is linspace will kind of calculate the increment for you based on how many numbers you want inside of your array. So the way to interpret this is that we're going from 1 to 35, and you want to have a total of 10 numbers inside of that array. And so in order to get from 1 to 35 with 10 numbers, oh, I'm sorry, it's going from 1 to 10 with 35. I said that backwards. So it's going from 1 to 10 with 35 numbers in between, and that's why we have this irregular patterning here. Is the decimal is because it's going to take like an odd number, or fractions of numbers, for you to have 35 different numbers inside of that array. And so to try out linspace, let's do this one. Let's have 0 be, remember, it's beginning, end, and the number of numbers inside of the array. So the beginning is going to be 0, the end is going to be 2 pi, and we want there to be 10 segments in between that range. So we can do x equals linspace 0, comma 2 times pi, comma 10. All right. And now we have a new set of numbers here for x. And I can pull that up just to see. Okay, we've got all the way up to 2 pi, which we know if pi is 3.14, then pi is going to be double that, so 6.28. So there's 10 numbers, just like we wanted it to, from 0 to 2 pi, 10 numbers. Now, what if here in the command window, we want to know what is the 6th value in that array? Then what we can do is we can give it this command x, and inside the parentheses the number 6. And that's going to call out the 6th number in the array and report it on the screen here. So that becomes our answer, 3.49. So if we want to know the 10th value in the array, then remember that was 2 pi. Or the first value in the array, which was 0, our beginning range. So it's an alternate way to look at the data. One of them is just to open up and look at the variable through this Excel-like viewer, and the other is to put which value we want to see inside parentheses. Did everybody get that? I'm just curious, how many of you for the homework assignment use Octave installed on your own computer? Looks like about half. How many of you came back here into the lab and actually did your assignment in the lab? The majority. And so there must have been very few who bothered using the remote, MU remote. Anybody do that? Oh, a few of you did MU remote. Okay. Free trial? You didn't mind the 4 GB download on your computer? All right. I guess it doesn't matter if you've got the patience to install it. 30 days should be plenty, right? If for a 30-day trial, we'll be finished for the semester by the end of that trial expiring. So, yeah. Okay. So remember, we had this this previous. Well, our answer was this operation. I don't think we assigned it to x yet, did we? Did we? Okay. So we assigned that array to x. What if we wanted to change a value? Now you already know that you can double click on it and go into that Excel type environment and change it. Or you can sort of snip out and replace individual values inside the command window as well. And so for that array that we've got, let's just call on x and it'll report x. And so right now, our 7th value, let's see, 5, 6, 7. So the 7th value we have right now is 4.1888. So if I wanted to replace that, I could say x parentheses 7, so is equal to, now if I just pushed enter right now, it would tell me what that is. Okay, but I don't want to know what it is. I want to replace it. So x7, the 7th value in that array, now I'm overwriting it with the value of 0. So I've redefined it, and then it reports back, and you can see here where previously we had that 4.188, now it's overwritten it with the number 0. And I can do more than just a single number at a time. Here, this is showing me that we can say x parentheses 2 colon 4 is equal to 3. And so it's going to overwrite number 2, number 3, and number 4. And so now, instead of being based on pi, we have some of these variables that are calculated based on pi, and others that we've manually overwritten. I can open that up and see that some of these are the ones that I manually overwrote. This was calculated based on pi. This was one that I manually defined, and so on. The point isn't the variables themselves, but the point is the syntax, learning that you can get an array and, if needed, make adjustments. Why would you ever need to do that? This isn't just all abstract. You know, in engineering, we learn things because we want to use it someday. This isn't like the basic sciences where we learn about electron valences just because it's somehow intellectually stimulating. I mean, everything we do is because somewhere down the line, there's a physical application. Something's going to get built, and either the way that it's designed is based on some math that we have to learn, or the underlying theory is based on the science that we have to learn. So here, being able to edit these variables, sometimes we have data sets. Like we'll go gather data in the field. Like maybe you've seen like they look like a garden hose across a road. Have you ever been driving on a road and it looked like there was a black garden hose connected to a little box on the side of the road? Anybody know what those are? It can detect speed, but it mainly is used for traffic count. But if you know how far apart the axles are, then it can detect speed. Or if there's more than one of them, it can detect speed. So that's an example of gathering data. And if you think about how many cars would drive over those in a day, it's an enormous data set. And so Matlab is a software program that's really well suited to huge data sets like traffic data. But sometimes we may have outliers, like where the instrument was malfunctioning and we have to go in and snip out or change or overwrite some of the field gathered data with values that we either know to be true or we want to just throw it out entirely. And so just as a potential application, and this isn't just all abstract nonsense, you know, you would need to potentially change an array if you had field data and some of the physical field data was faulty. Now, I don't do transportation. I do environmental research and watershed analysis. And in my case, a lot of the data that I have to look at is rainfall data. And then that's another one that there can be errors in rainfall data where the equipment is malfunctioning or the rainfall intensity is higher than the equipment is actually set up to measure. And so sometimes when that data is being audited, they have to go through and make adjustments to the underlying data set. So it's really important to know all of the different ways that you can modify a huge data set. And this is one of the valuable ways that we have to do that. Okay, so here's our X array from before. This is where X stands right now. What if we wanted to replace values 2 through 5, so 2, 3, 4, 5, with an array? So if we want to just completely substitute, now remember what the command 2:2:8, that says we're going 2 through 8 in groups of 2. So having it say on the left-hand side of this equal statement is where it should go in this array of X. And then on the right-hand side of that equal statement is what should actually be put in there. So now we're combining a couple of new ideas from today. This is where it starts to get a little bit more complicated, is both the left side and the right side have calculations and commands based in that. And so let's do that. Let's go into Matlab and overwrite our existing values of what's in X. And so let me just remind myself what is X. I'm going to call on it. And close this. All right. So X. All right. So it tells me what is X. Now I want to replace that. So I'm going to say X 2 through 5. So I'm defining what I want to change right now, the second, third, fourth, and fifth values in the array is equal to, now the brackets there tell it I'm inserting a different array inside of the target. So 2:2:8. So it's going from 2 to 8 in spacing of 2. And so I didn't suppress that one because I wanted to see what was the result. And so now we can see here was the old version before I did the surgery, matrix surgery. So we inserted the new values and it worked out just as we'd hoped. But it has to be the same size. We couldn't put in 10 columns if there was only 4 columns of space in there. All right, so let's now talk about polynomials. Probably you've seen polynomials plenty of times in math, and you'll see polynomials again if you come into my hydraulics class. I'm teaching hydraulic engineering this semester to juniors, second semester juniors, and they have to solve polynomials a lot in the case of open channel flow through rivers and canals, trying to find out how deep the water will be. That ends up being, in a lot of cases, solving for roots of polynomials. So Matlab has some nice tools to solve for the roots of polynomials, to graph polynomials, to find out the result of a function for a certain value of X, and so on. So let's investigate some of those tools. And before we do that, though, we should try and understand how to represent a polynomial as an array in Matlab. And so we're going to use a polynomial as a one-dimensional array, meaning that it only has a single row, but it can have multiple columns. And the number of columns this array will have depends on what power X is to. And so, for example, if we have a polynomial 8x plus 5, that's a 1D array, meaning it's just a single row, but it's a 1 by 2. So 1 row, 2 columns. X is in the first column, and then just the single coefficient of 5 is in the second. Obviously, the more columns we're going to add to this array, the one that's furthest to the left is assumed to have the most X. And so the way that we maybe could find out what the polynomial is 10 is just the coefficient, then it's minus 4x and 2x squared. All right. Now, if the polynomial is 6x squared minus 150, inside what we've written here, there's no x value. But we still need to put a placeholder for that x, where that x would be inside of Matlab. We couldn't just have 6 comma minus 150. If we typed that into Matlab, it wouldn't know that the first value was x squared. It would have no basis of reference for that. And so the way we force it to understand the first number of 6 was x squared is by putting in the 0 kind of just as a placeholder. So it's x to the 0 power. So there is no x value. And so here we'd need to have a number of placeholders to represent 5x to the 5th plus 6x squared minus 7x. So if we want that to be as an array in Matlab, we're going to have 5 followed by comma 0, comma 0. And this is x to the 4th, x to the 3rd. Both of those don't exist, but they need to be placeholders in Matlab. 6 is the x squared minus 7x, and then the 0 placeholder at the end for the fact that there's no coefficient. Any questions about this approach? Now, you can use the function polyval to evaluate a function to find out what is the result of that function at a certain value of x. So first of all, let's get some practice defining a polynomial in Matlab. So type this in for the variable c. Now, as I was preparing for today's lecture, I had one small difference. I accidentally typed in minus 12.2 instead of minus 12.1. And then later on, it all fell apart. Like I wasn't getting the answers to match up. And I had to keep reminding myself, no, Matlab isn't screwing up. Your finger's screwed up. It's not a computer error. It's a user error. So define this variable.
How does it know that it's a polynomial and not just another array?
Oh, good question. So he asked, how does it know it's a polynomial and not just another array? The fact is, it actually doesn't matter. It is just an array. It's what we do with the array that kind of makes it a polynomial. You know, we're going to take some array that exists and we're going to start using polynomial functions on it. So that's an excellent question. It doesn't know that this is a polynomial. It's just, as far as it concerns, just another series of numbers. But we formatted it so that it'll be appropriate for use in this polyval function. All right, so I'm going to do c equals brackets 1 minus 12.1, 40.59, negative 17.015, minus 71.015, 71.95, 35.88. Yes? You're right, I didn't. Thank you for catching that. If I paid a bounty for students catching my mistakes, I'd be a very poor man. I'd be basically broke. But I'm glad to have you doing it. All right, so we've defined C. Press enter. It shows up in the memory here. And now we want to do polyval C, comma 9. So the syntax of that is we're telling it to evaluate variable c as though it's a polynomial function and let the function be equal to input 9. So in other words, x equals 9. If you put this into your calculator, what we're essentially saying is 9 to the 5th power minus 12.1 times 9 to the 4th power plus 40.59 times 9 to the 3rd power, and so on. We're evaluating the function at a value of 9. So I type enter to that, it thinks for a moment, and then it gives me the answer. It should be 7.26 times 10 to the 3rd. So that's 7,261.1. It must be formatted as scientific right now. Anybody remember what the commands are to just get it to format it as a number rather than as scientific? I think it's format long, right? No? Well, now, yeah, I see all of the digits, but it's still scientific notation. Well, format would give it as decimal 2. Format bank would give it 2 decimals. Yeah. All right, well, let's not focus on that formatting fixation. Okay, so that's our first evaluation of the polynomial at a function value of 9. Did everybody get that answer? Okay, we can also have it solve for the roots of a polynomial. And remember, if you want to actually see the roots, then you shouldn't suppress it with the semicolon. So roots of C. So here it's going to find the roots. Roots of C. There it is. Okay. Now, you have the Casio calculators, right? It'll solve polynomials. I think when we were doing it earlier in the semester, we could take it up to the 3rd power, if I'm not mistaken. But this one was a polynomial to the 5th power. So this isn't one that you could really easily solve for with your calculator. You could solve for it graphically. You can graph the function. But here now Matlab is giving us new capabilities. Okay, we found the roots. Speaking of graphs, let's try plotting it. So if you want to plot a polynomial, you can use the plot function. And let's, first of all, create a range that it will plot with. We're going to set this array of the beginning is -1.5, the end is 7, and we want it to do it in increments of 0.1. So before we plot the function, we want to specify the range that it should do so. Okay, so let's set x range of plotting. We want the x values to be between -1.5 in increments of 0.1 and going all the way to 7 before it terminates. Okay, so we've defined x. Now we want the y to be the polyval c of x. We want to, in this, we're saying C was our polynomial itself and evaluated over the range of values inside of x. So x was an array with a certain number of values. So find out what is y for these certain x values and then plot x versus y. It'll think for a moment, and if we're lucky, bring up a new value, a new window. I might have accidentally closed that window. Here it is, hiding. Okay. Now, we found some roots before, numerically. Let's see if those roots match up. What we should be looking for is where is the value of y equal to 0? And so before we had a root at -1.2. It looks like here's one of them. Our next one was at about 1/2. There's the crossing at 1/2. There's another one at 2.3. Here's the root of 4. And then the last one at 6.5. And so both the graph and the roots that it calculated before seem to be consistent. But in the notes that you're taking, what you should write down is the syntax for how you got it to graph that polynomial. The first thing that we had to do, we had to define the polynomial. That's where we had this variable c. The array c contained the the coefficients before each of the x values. And so one of them was x to the 5th, x to the 4th, and so on. So c it already knew. X was the plotting range that we defined as a variable. And then we told it, once we had x and y set up, a series of x values and a series of y values, then we plotted x comma y, which was an array. Now the nice thing is that y had exactly the same number of values as x did, because y had as one of its inputs x. And so x and y had the same number of values for us to look at. Okay. We can multiply polynomials together with a function called conv, which stands for convolution. If you wanted to multiply these two pieces together, you've done this before, right, in algebra class? Take a moment to write down what that should be. The result of it. It's always good to double check. The first time you try a command, use some familiar data on it so that you know if it's working as you expect. Double check the computer, not that you're wondering if the computer is working correctly, but if you're checking your understanding of what it's actually doing. So if we multiply these together, then what we could do is, first of all, define A. So let's do it the computer way. Now that you've done it by hand, define A to be 1, 0, 1. Now what is that? That's x squared to the first, 1 times x squared, 0 times x, and then 1 as the coefficient. So we've set up A. Now define B. So we've got these two pieces together. These two polynomials are just a couple of arrays. And then you can multiply an array by another array with the convolution command. So convolution A comma B. We'll multiply it. And if you don't suppress the echo, then it should give you the answer. And so what that is saying, when we see that array on screen there, it's saying 2, 7, 2, 7. And so 7 is the number, and this is x to the first, x squared, and x to the third power. And there's no negatives there, and so it's all pluses. Is this what you had written on the paper for the result of those two pieces multiplied together? Yes?
Do you have to label have A equal that, or could you actually just put the equation in the
So you're saying, could you put the array rather than a variable? That's a good question. Let's try it out. I don't know that I've ever tried. So his question is, do you have to assign the array, or can the array go in the convolution? So what if we did convolution, and now, all right, so our array will be 1, 0, 1. And then the other one would be 2, 7. Seems to work. You don't have to assign it as a variable as an intermediate step. And now we've all learned something new today, including me. Other questions? Programming is rarely people's favorite thing, especially, like if programming was your favorite thing, you'd probably be in computer science. So you guys are being awfully good sports about this. I don't hear as many groans as I think, maybe you're groaning on the inside. But good job, guys. I just want to give you a good job. Keep up the good work. Thank you for not complaining about programming, because I know if it was your favorite thing, you'd be in a different major. All right, curve fitting is a way to interpolate or to take some given data and try and find a trend. This is something that's really common in engineering. Generally speaking, we have two types of equations. We have fundamental equations and empirical equations. Fundamental equation are things that are based on like immutable laws of the galaxy. You know, like you can find the velocity of something by knowing its acceleration and how much time has elapsed. That's a fundamental principle. But then there are these empirical equations that are just based on lots of measurements of the environment. Like if you wanted to know the relationship between education and income, you could make a scatter plot of that, but there are going to be a lot of exceptions. Some people who have very little education end up making millions, and some people with lots of education end up making very little. And so we could look for a trend in that data, but it's not necessarily a fundamental relationship. So Matlab has the ability to do essentially a trend line in the same way that we did with Excel. Remember when we had it insert a trend line and then we'd ask it to tell us the equation of that trend? I think that you had on an exam, was there one related to bullet weights, trying to predict how much would be the cost of some bullets based on the best fit line? Okay, so there's something similar in Matlab. Let's say that we have this data. Here's an X versus Y data set. Looks like this may be a bit of an outlier, but nevertheless, we have data points. Let's define those data points and see if we can use Matlab to estimate what values would be in between based on the equation. Okay, so let's redefine, by X and Y are getting a lot of use today. So X is going to be we actually have to type this in. In this case, since this is actual data from the environment, it's not like we're just evenly spacing some numbers. These are just values that we measured, and so we have to key them all in or import the data from another file. I didn't bother typing in 4.0, 6.0, and so on. Just the numbers themselves is sufficient. All right, so we've got X and Y. Now, we want to have it interpolate between the 2 points and find out if X is 2, what should Y equal? So just look at the data and try and guess if X is 2, what should Y be? I mean, it looks like it's maybe going to be about 2. Just based on our eyeballing of the data. But the way that we could ask Matlab to do that is this interpol 1. That's not an L. Interp 1. And so what we're telling it is X, Y, and 2. So X is the input for the first set, Y is for the second, and we want to know if X is 2, what is Y? So let's try that command. interp 1, X, Y, 2. All right, 1.8333. So it did two things in there. It created a best fit line. We don't see the line, but it knows it. It's sort of calculating it on the fly, the equation that relates X and Y, and then it's inserting the value of 2 into that equation, and it's giving the result. Yeah? Yeah. That's right. Yeah, let's try that. Interp 1. If we swap the variables. So now it's saying 2.25. That might have been one of our actual data points, right? If we go back to the data, when we were defining the variables, no, it wasn't. It did the interpolation. All right. Now, if you want to fit a curve, you can use polyfit. And you remember that when we were working in Excel, there were different options for what the line should look like. It could do a linear best fit regression, quadratic, cubic, and so on. So for the data that we've already defined, if we wanted to know what the equation is, and it's a cubic regression, then what we could do is polyfit. So try polyfit x, y, 3. And the 3 here means like version 3 of polyfit, which is the cubic version. And so what it'll do is it'll now tell us the equation for that line, the best fit equation according to cubic regression. So here is the interpretation of that output is y is 0.22 x cubed and so on. Or if we wanted a linear version of that equation, we do polyfit x, y, 1. And so in the linear version of that, it's saying that y is 0.5688x plus 0.9982. Maybe it's a little bit less user-friendly than Excel, well, where you're using mouse commands, right-clicking on the data and insert trend line. They've made it a lot more user-friendly in Excel, but the limitation with Excel is that it has hard limits on the number of data points that can be included. And here we can do more than just one-dimensional arrays. You can also do calculus in Matlab. For example, taking the derivative of a polynomial. If you've taken some calculus before, then you know, for example, you could take the derivative of this function, 3x squared plus 2x, minus 2x plus 4. If you take the derivative of this with respect to x, then what it's doing is it's taking the x squared, taking the 2 down, multiply it by the 3, so then it becomes 6x. The x in the second field here goes away, and then since there's no x with 4, it just vanishes entirely. So the derivative of that function, we know what it should be. If you do the same thing in Matlab, take the derivative, first of all, define a function, and then take a derivative. Let's try that out and see if we can get it to work here. So we want to, first of all, define C as our polynomial array. 3 minus 2 and 4. So that is a 1 by 3 array. And then I want to take the derivative of a polynomial, and it's going to be variable c, and it tells me the new function once you take the derivative with respect to x. Here are some other functions that can be useful. You can take the mean of an array, which when we were in Excel, that function was called average. But there's maximum, minimum, median, sum, standard deviation, and then you can resort the data from smallest to largest. So these are sometimes called descriptive statistics, when you want to kind of know what you've got in your data set. If it's population data and you wanted to know information about the range of ages or the average income or so on, these are all tools that you could use to analyze and get a handle on what's inside of your array. Any questions about what we've done today? Well, I know that things are heating up in your other classes. Probably you've got projects and reports and so on. So this is a rare instance in which your engineering class is giving you a bit of a break. Just to revisit these announcements, we don't have class on Thursday. We will be back in class at our normal time and location on Tuesday of next week. And you don't actually have a homework in your hands right now either. So I'll give that to you in class on Tuesday next week. And if you have any questions in the meantime, after you're just maybe practicing things, feel free to let me know. And I'll suggest again, as I have previously, have a look at MU Online, and if there are any discrepancies or if you've got concerns or questions, feel free to stop by. Also, if you came in after I took roll, please come up to the podium and let me know so I can adjust the grade book. See you next time.